Welcome to another devlog update. It's been a long time since the last one. Anyone following will know that I've done in the interim a couple of tutorial videos, a couple of episodes in a sequence of tutorial videos. I will be getting back to that shortly, but this is an update to the last devlog, which is intended to bring you all back up to speed on what's been happening behind the scenes, how Kwyll is developing new features, current status and so on. I want to make this video two parts. So in the first part I'll do a typical devlog which will go over what's changed since the last update, new features, new nodes for the logic, that sort of thing. And then in the second half, because we're getting close now to a beta release, I just want to quickly go over from a high level all the different features that are in Kwyll at the moment. So I'll do that itself in two parts. Firstly, just going through the user interface, showing what's in each tab, what each part of the user interface does, why, how that affects the game. And then in the second part, I want to just list, as an example, all the different nodes that are in the logic, because the logic is without a doubt the most important and critical part of the Kwyll tool. It's what enables you to create a variety of different types of games. It's intentionally designed to be powerful and flexible, so that you're not tied to a particular type of game. So that list of nodes, that list of capabilities in the logic system has grown dramatically during the development of Kwyll, and I just wanted to quickly just give a high-level view of just how much is in there. So that's where we'll finish in terms of the update. And then at the very end of the video, I'd like to just quickly go into my plans for a beta release, which is coming up very soon. The feature set is all but locked down, and I'm just cleaning up a few things and doing some optimizations. So very soon, hopefully, we'll be in a position to do a beta release. So I want to just cover a little bit on what that's going to look like. Okay, so first of all, I'd like to go through what's changed, the new features since the last update. There's a lot to cover, so I'm going to cover them fairly quickly. I'm not going to go into too much detail. Where it's important, I'll refer back to previous videos for you to go back and get a reminder, as it has been a while. But if anyone's got any questions, by all means, just pop in something in the comments below, or pop over to the Discord, and I'll be happy to clarify anything that I've rushed over a little bit too much. There's a lot to get through, so I don't want to spend too much time on each one. It will drag things on. First feature I want to touch on is how player navigation around the map works in Kwyll. It's worked a particular way for a long time, and that way I've been well aware has had some problems and limitations. So I've reviewed that whole process and come up with a new way of doing it. So I'll go into that now, explain what it used to do very briefly, and how it's changed. So if we go to Kwyll itself to begin with, so easiest way to explain this is if I open up one of the samples. So if we go to this game and look at the map, you can see on the map we've got 4 locations. 3 are interconnected properly, they're actually adjacent to one another, and 1 which is disconnected over here, which is the interior. Now the way the navigation used to work is whenever an object was moved using the move object logic node, particularly a global object or a map level object such as the player here, if it moved off or outside of the current room, the system would automatically determine if the new location was if the new position in map coordinates was in an existing location on the map, and move you there. Now this was fine in most cases, but it did mean that if you had multiple objects moving, because the logic was being executed every time an object would move, sometimes you'd get into the situation where there would be conflict. One object would move into a particular location, another object, say an enemy for example, would move into another, and they would fight about where to move to. So I've improved that and changed the way it works and made it much more controllable. So if we go to our player object, you'll see there's a flag on here, which is player. That identifies a particular object as the player object. So if we go to start room, we've got some objects in here. You'll see none of these are marked as player. So that's the only feature for that flag at the moment. Is it will, if you move the object around in the map, it will automatically go to the correct location for that object. That's basically replicating the previous behavior, but it allows you to control which objects it works on. So you would typically only set one object in your game as the player. The other way that you can do it, if you want more fine-grained control, is there's a logic node. So if we go to the logic quickly, and I'll show you the logic node, which just allows you to go to a location at a particular map coordinates. So if you pick your map coordinates as 37446, for example, and you plug those into here, it will just take you straight to that location. So that gives you just much more control over how you move. But most people will probably use the flag on the object and just make your rooms adjacent on the map properly. Second feature that's changed since the last version is the ability to set variables on a screen, their initial state in particular. So screens have had logic ever since they were introduced, and as with all logic, you can add variables to the object that contains the logic. So this screen has a single variable debounce. But before, there was no way of actually setting that variable's default state. So you'll see here, this is a hangover from the previous approach. There's an initialize flow here which sets the variable to 0. So what I've done is introduce the ability to set the variables on the screen properties in much the same way as you do on objects and locations on the map. So this value, if you set this value here in the screen properties, that's what it will set the variable to when you start the game and when you restart. So it's just an easier way of doing it, and these two can actually be removed in the new world. The next feature or next change, which is just basically a consistency thing, is there are various places throughout Kwyll where you set color on tiles, on objects, on rooms, locations, etc. And they all had their own quirky ways of setting those in the user interface. So I've gone through and I've replaced them all with a common control that is used everywhere, and it's for two reasons. Firstly, for consistency of the user interface, so you get familiar with the way that color specification works, and it feels consistent and comfortable. Secondly, making it a single control means that when we move to other platforms, such as the Commodore 64 or the BBC or Amstrad or whatever, which has different concepts of color, I can have that user interface component plug in and out with the right one for your target platform. So just to very quickly show you one example of it, in tiles properties you have this color option here. So you can set the ink and the paper color, and the X option means leave it to whatever the default is, and you can set the brightness, and again you've got on or off and leave it to whatever the default is. So this is how all color specification should look throughout the user interface elements within the main Kwyll tool now, so that it'll all be familiar, and what the defaults are will be described in the documentation for that area. So that's just a consistency thing, and again future proofing for when we move to additional platforms. The next feature came around because I was working with some of the Patreon supporters who were using the early access version and hitting some problems with the logic. And a lot of the times the logic, the problems they were hitting was not being clear what the different nodes do and what the different ports into and out of each node do. So while there is the description here for each node, it gives you a short description of what each node does. It wasn't always clear what each of the inputs and outputs would do. So I've gone through each of the nodes in the current node set, and I've added tooltips to each of the ports. So if you hover over the label for a port, it will pop up a short description of what that input means, or what it expects in the case of an input port. So in this case, this is the X coordinate, top left tile to modify, and specifically in room tile coordinates. So it tells you exactly what it expects and what format it should come in. You've got things like collisions and ink and so on. In the case of a node that has an input port and an output port in the same row, you hover over the label and it will give you both. So the input is the left operand to the math operation, and the output is the result. And in the case of a single one, it'll just give you the right operand. So that should make it a little bit easier, along with the descriptions in the create node here. It should make it a little bit easier to understand what you're doing and get clarity on what to expect. And maybe when things aren't working as you expect, you can hover over these and just see if you've made a mistake in providing the input data, to make things a little bit easier. Next feature, something that's been needed for quite some time, is more control over the colors for each object instance. So this is a feature to make objects more generically useful, while giving you some control over how they look on screen, without having to make lots of objects just because you want to change the color of one. So we've got two places where you can control the color of an object, and we're in the room editor here. So these are two room objects, character 1 and character 2. And if we look at the object definition for the character, it has color in the properties, which means these are the default colors for any use of that object: red ink on blue paper with brightness off. And this one here is red ink on blue paper with brightness off. So that's basically just, we've taken the object and we've dragged it on. This one here is exactly the same object, but in the instance properties, which you pop up for each instance of an object, you can override those colors. So this one overrides them with yellow ink on blue paper. And so that allows you to specify a color on the definition and a color on the instance. And the same thing applies in the map. So where you create a global object, these are two global objects. This one, again, has no override, so it uses the object definition colors, red ink on blue paper. This one, if you open this up, overrides the colors to white ink on red paper. So that gives you complete control over how you specify the colors. And as you can see, there's only one character object, but it's used in, if we go to the preview, it's used in multiple ways. And in partnership with this ability to set those colors is a new logic node, which allows you to set them from code. So in this switch, this simple switch, we set those 4 character colors to something else. And if you play it in the preview, we move over the switch, you'll see that each of the objects changes color. And then this switch resets, does a game reset, so you can see it resets the colors to their defaults. So the defaults are kept and can be recalled when you do a reset game. So the next feature, it's a very small one, but quite a useful one. This is a subgraph. There's a video describing what subgraphs are. I'll link them in the description below. But within this subgraph, so if we go down into the subgraph, you can see we've got an input here, speed, named speed, which come back up again, shows up here as speed. Now, before, that would be all that you would see. You'd see speed as a label and the port, and you'd have to use a number as we have here, or some other node tree to feed in a value to that port. Now, if we just disconnect this one, the new change allows you to specify a constant input, so we could just do it that way and do away with that node altogether. It just makes things a little bit cleaner and more efficient because you're exporting less nodes, less logic. So if you know that your subgraph in this particular use case has a fixed value for that thing, you can just type it in directly. Next feature is a more additional nodes. So before you had no way of looping or doing things in a repeated fashion. If you wanted to do that, you'd have to basically duplicate each the node tree that you wanted to do multiple times, as many times as you needed to do it, which obviously is very, very inefficient and not ideal. So I've introduced two new nodes, loop while and repeat, which do looping functionalities. So they both run what's connected to the body output port, flow port, multiple times based on a condition. So in the loop while, it'll continue running these two nodes here while the condition is non-zero. As soon as the condition reaches 0, it exits, and it'll run. It will continue with the flow on the exit if there is one. So this one basically sets a counter to 5, spawns an object at a position calculated by the counter, reduces the counter by 1, and goes back round again until it hits 0. And the repeat is very similar. It allows you to set a start value and an end value and a step for an internal variable, an index which you can get access to in the rest of the flow, and runs the body as many times as necessary until the index value reaches the end value. So this one will start at 0, so the first time through it will be 0, then 10, 20, 30, 40, and then it will stop at 50. And then you can access the value here to spawn that object. One caveat on this, word of warning, it is easy, especially with the loop while, to get Kwyll into an infinite loop that will never exit. So you have to use these things with caution. With great power comes great responsibility and all that. In the simulator, there will be a way of exiting, so you're not going to crash and lose your work. But when you export, if you haven't taken care to make sure that the looping is clean and will exit, you will lock up your machine or your emulator. Next one, another new node. This is get tile info. So this is a node that will allow you to get the information of a tile, if there is one, at any tile coordinate in the current room. So if we go to the logic for our player, you'll see we've got this get tile info here. It takes X and Y as tile coordinates. So that will be the cyan coordinates are tile coordinates there. So these are the coordinates you'd be getting. And it returns either the tile type from, so this is 0, 1, 2, 3, 4. So it'll tell you which tile is there. The collision information, up, down, left and right. The color, which is a combination of ink, paper and brightness in a spectrum specific format, which will be documented. And the type, so if you remember, we have in tile properties, we have a custom type. So it'll allow you to get that type. So you can assign that type for different meanings within your game and use that. That's useful. If I just quickly show you how this one works. So if I move the arrow across, it's calculating the tile coordinate and getting the information for that tile just below the arrow and printing it into the instruments. So you can see that it's reading out all the different stuff. So moving on to the next one, we've got another node. This is relatively simple on the surface, but really important to understand the value of. It stores a value. So quite often you'll find yourself with logic. So in this example here, we've got a whole bunch of logic back here that gets executed to get this single value, which would normally be used as the X value for this get tile information. Now, if, as in this case, we have multiple uses of the output from this tile, so each one of these set instrument nodes will request the data from the get tile information node. It in turn will request that value for the X from the graph further back. Now, if we had connected this directly to there, for each one of these 4 output values, it would have to execute this graph to get the X value. And more importantly, when exporting, it would export the code for that entire graph 4 times. So which is both costly in terms of performance and memory, but also completely unnecessary, because the first time it's executed, that value isn't going to change for the rest of this flow because of the way this works. Not always the case, but in this case it is. So the store value, what it'll do is it goes into the flow, so we complete the move object, and then we store the value of this calculation, all of this information over here, and we store it in a memory location associated with this node. So then when getTileInformation asks for the X value 4 times, once for each of these, this node will just give it what it's already pre-calculated. So it doesn't need to export this graph multiple times. It doesn't need to calculate the value multiple times. It calculates it once and then just repeats it each time it's asked for it. So that's really important to understand when to use that. If you've got a complex flow here that's going to be used multiple times, such as in this case here, where you've got multiple outputs that will trigger that, it's really important to place these in key places to make sure that you store the value and don't recalculate it every single time. Next we have 4 more new nodes. Now I've mentioned in the past in other videos and in the tutorial that there are different coordinate systems. I've tried to keep it to a minimum, but there are different coordinate systems in use in Kwyll. Room coordinates, so if we create a room, so room coordinates are local to a room, so it'll always be 0, 0 to the room, the game screen size within the room. And if you place a room in a map, no matter where you place it, room coordinates will always be 0, 0 here down to the room size there, no matter where you put it. And then there's map coordinates, which are 0, 0 here and extending out into the size of the game area, which is quite big. So this allows you to use rooms multiple times. So if I put a room here, another room here, exactly the same room, if I access coordinates in room coordinates, this coordinate here will be exactly the same as this coordinate here. But if I get them in map coordinates, they'll be different. So these 2 new logic nodes allow you to convert between those coordinates. So you have a point, such as a marker, that's in room coordinates. You can convert them to map coordinates. For example, if you wanted to place a map level object at that point, you can do that by converting them. And similarly, if you have a excuse me, a global object or a map level object, such as the player, and you want to work out where it is in a room, if it's in a room, then you can do map to room to convert the coordinates X and Y into those 2 coordinates spaces. And then the other 2 are pixels and tiles. So within rooms you have the concept of pixel coordinates, which are the white ones, 0, 0 down to the screen size or the room size here. And then you have tiles, which are 8 by 8 tiles. So there are some nodes and some logic elements that you want to have coordinates in tile coordinates. So this is 0, 0 and this is 3123 because it's a full screen game window. So these 2 are just the same thing, but they're allowing you to convert between pixel coordinates and tile coordinates for using those values. Next feature is a change in the way that a particular logic aspect works. So it's around moving objects. Prior to this change, there were 2 move object nodes. One that would move an object to a particular location and report back through a separate flow if the move resulted in an intersection with another object, and allow you to do something based on what object was intersected with. And a second one, which would have been used here to check, so it moves to a particular location and reports back if the move resulted in a collision with the collision information in the tile map, and it will tell you which direction the collision occurred in and how the system prevented interpenetration of those two elements. This was not flexible enough in that you could only detect intersection with one object, and only the object that did the move, so in this case this ball, would get the notification that it had intersected with another object and what that object was. So I've changed it to make it much more powerful and much more flexible. So there's now only a single move object node. All it does is move the object, and then it will carry on if you want to out of this standard flow. But I've introduced two new triggers. This one is collided, which will get executed if during the move, if this move resulted in a collision with the background tiles, and it'll give you information about which side caused the collision. So if you're moving down, it would tell you that the collision was on the upside of the tile. So you've probably seen this sample before. It just allows you to detect collision with the collidable tiles and do something, and this number down here is giving you that value of the sides that were hit. Okay, and then the other type, if I just very quickly load another sample, look at our player object, if I can find it. So this one here. So again, before we've got this move object here which just does the move and then goes off and does everything else. Before, you would have had a flow out of here that you could follow if the move resulted in an intersection with another object. That's been replaced with another trigger type. So if during this move, the new location is intersecting with any other object or objects in this case, this flow will be called on this object with the other object that it intersected with as the reference here. So you can check the type and do whatever you want to do based on that. But more importantly, the other object that you intersected with, the ref here, will also have any object hit flows executed on it with this object as the ref. So they both get to know about the intersection and they can both behave appropriately. So this allows you to separate concerns. So for example, if a key or an object that you want to be able to collect could have an object hit flow on it that checks to see if it's the player and collect the key, which means that the key knows about what it needs to do when it's hit by the player. The player doesn't need to know what a key is or what a collectible object is. The collectible object itself maintains that knowledge and logic, so keeps it a lot cleaner. It also means as a side effect that you can have multiple intersections. So moving an object, or the player for example, to a new location could result in an intersection with a key and an enemy, for example. In the previous example, only one of those would result in a flow, in a response, because it could only detect one at a time. In this new system, all objects involved in all collisions will get these triggers, so it makes it much more flexible and powerful. Next feature is also more to do with logic, but also a little bit with the engine itself. So I've introduced some more flags to object instances, and you can see them in here. So these bubbles, if I open up the properties, you can see we've got some more flags in here. We've got the player, which I explained a moment ago. Intersect object and collide with background have always been there. These are deciding whether or not this object will interact with the background and with other objects. These two are new, visible and active. So visible describes whether the sprite is actually visible or not. And active describes whether it describes two things. Firstly, whether logic will be executed on it. If it's inactive, no logic will be executed on it at all. And secondly, it interacts with other objects. So if an object is inactive, it's effectively overriding this intersects objects flag. So if it's inactive, it won't be considered when you're moving objects around to see whether they collide with it. It's mostly useful for things like dynamic objects, but they are independent of one another. An object can be visible and inactive. It can be invisible and active, and you can choose how you want. So you set them in here in the object properties as their default value, and you have some logic. If we go to the switch, I believe, yeah. So we have a new logic node, set object flags, which allows you to modify those key 4 flags. Intersect objects, collide background, visible and active, and you can set them to leave, so it just doesn't change what their current value is. So this switch here will set both of the there's 2 room objects. There's three bubbles, and it will set the various flags on them. So if we go back to the room very quickly and look, this one here starts off invisible, as you can see. So you can see it now, but when you play the game, it'll be invisible. This one doesn't have intersect collide with background set, so it will go through the wall. This one, it's a different one. It has some logic on it. It's a bubble too. It's a different type of bubble, and this one has so the bubble animation isn't done through typical animation here. It toggles between the 2 animations using logic, which means if the active state of that object is set to inactive, it won't animate because no logic is being executed. So we can see this in operation here. If we just see that the first one is invisible, this one is animating nicely because the logic is being executed on it, and this one goes through the wall. If I move the player over and toggle the switch, this one becomes visible. This one is set to collide with the background, so it can't get through the wall anymore, and this one is set to inactive, so the animation doesn't play. Next, we've got another small change, but useful change to the logic. If you remember, we've got the concept of these markers, which are very lightweight position-only objects that can be used for things like spawn points or other things where you want to visually place something in the map and then use it in logic. So before, the only use you had for these markers was a logic node called transport to marker, which will just transport an object to a specific marker location directly. So that's how you would typically use it for spawning an object. You spawn and then move to the location. But in order to make them a little bit more generically useful, I've added a simple node that lets you get the position of a marker in a particular location, which you can then do whatever you want with. You can convert it to map coordinates to move a player, or you can I don't know, check to see whether a player is close to a marker or whatever you want to use that marker for. And it's just another useful way to be able to take advantage of the visual placement of these markers in your game logic. Next, we've got some more useful nodes that have been added, in particular related to variable access. So up until now, so anywhere that has logic, that's screens, locations, global and objects, have the ability to have variables on them. And up until now, screen and rooms or locations, the only use you had for the variables in there was within the logic on that particular screen or location or room, because there was no way of accessing them from outside. You could access global variables from outside, and you could access room variables from other logic flows, but not screens and rooms. So you can see here I've got a variable defined on this screen, so you can set the variable value there and so on. And in the room, in the logic for this room, I've got a variable defined. You would not be able to access those outside of the logic for the room. But now I've introduced location variable and set location variable, which allow you to set and get variables on any particular location. So you can set information based on certain things changing in a room, so maybe hide something or whatever. And similarly for screens, so you can set a screen variable and get a screen variable. So you've got complete access to all all variables across all logic types now. And next I've got a feature that I've added support for that Godot's had for quite some time, but I didn't even realize it was there, which a bit frustrating. So you may remember there's a comment node, which is an inactive node, but just allows you to put some useful information into your logic flows. They don't get exported or anything, but they can just be useful to remind you what something's doing. So this is how it's had to work up until now, because you can't place these on or around. It just messes up the logic display. So the way that you would typically use these up till now is just to place one close by a particular piece of logic just to remind you what it's doing. So but I discovered recently by accident that there's a feature in Godot since 4.3, at least 4.3, that allows you to do exactly what I actually wanted to do, called frames. So I've introduced frames into this editor. A frame is, in this particular use case, I've implemented it in the same way as a comment, so you can add text into here. But the key difference is this node, this feature of Godot allows you to place objects within the frame and they become part of the frame, so you can move the frame around. So we can move this one in as well. They can still interact with things outside of the frame, that's fine. So you can basically group a whole bunch of nodes into one of these frames, and just keep them consistent, and maybe add some text to describe what's happening there. So it doesn't change anything on the export, it doesn't change anything in the way that the logic flows work. It's just a useful feature to make using the logic from a designer's perspective more friendly and more organized. And in support of this, up until now, whenever you click with the right button, as I just did in the logic editor, wherever you were, it would bring up the create node selector, whereas now it pops up, if you right click over an existing node, it pops up a context menu which allows you to delete. There will be more in there, but for now it's delete. And if it's in a frame, it'll allow you to remove it from the frame. So that one's now no longer in the frame, and we can remove that one from the frame too. And then the frame is no longer containing anything. It works as well as dropping a node into the frame. So you saw me drop that node into the frame, and then it contains it. You can do the same thing with the frame itself. If you expand the frame out to encapsulate the node, it just grabs it. So that's the first part done. All the details of the new features since the last devlog. As I said at the start, I'd like to go into a second part of the video showing a whistle-stop tour of all the features that are in Kwyll, and this is most likely to be the feature set that exists in 1.0. It's not likely to change much from here on in. So I'm going to go over each element of the user interface and try and touch on what features of Kwyll that element of the user interface covers, and hopefully in doing so we'll touch at least partly on each of the main features. I'm sure there'll be some things I miss, and if I do and you want any clarification on any of these things, ask in the comments below, or pop over to the Discord, and I'll be more than happy to answer any questions. So let's dive straight in. So starting at the top, we've got the toolbar. Obvious ones here: new, save and load, export for exporting to your chosen platform, which is Spectrum only currently. The code one's an interesting one. So this basically allows you to look at what gets exported. So everything that gets exported at the moment, as a result of recent changes, is data, but it's data in the format of a C header file. So this part probably isn't going to be much interest to many of you. unless you really want to dig into the details of how it works. But this side over here, the data tab, is really important for everyone. So this is where you get to understand where all your memory is going. So this empty file currently takes up 854 bytes, and what's it? Where's it going? So you can look into here. You can see the screens taking up 47 total. You can look at each screen and see which part of the screen. You've got rooms. This is a very simple example. Obviously, this is just the empty one. So if we open something up and look at the code, you'll see there's a lot more. You've got 5,000 bytes here. So you can look and say, oh, object defs are taking up 1,005 bytes. Why? The bubble is 146. 125 of that is logic. So you start to understand where your memory is going. Portals 25. We'll have rooms down here as well, which take up a huge amount, 3K of space. Start room. And then you start to see where things like the tiles and the attributes and the collisions, and this gives you a pointer to where you can look at the rooms and say, okay, so I've used a lot of tiles, or I've used a lot of collision information here. How can I better do this? How can I reduce that space and optimize? And there's lots of things, lots of techniques that will be detailed in the documentation for doing that. So that's a very useful button. Use it to understand why this number here is where it is. So then we've got the tabs. Oh, let me just cover this on very quickly. So this is project settings. At the moment, the only thing in there is the window size, which allows you to define the game window, which is this almost invisible blue area in here in the screen. So if we reduce that down to, say, 28 by 20, then you can see you've got a smaller game window. This is basically the size that your rooms will be. So if you create a room, now you can see this is the room. Anything outside of that room won't be exported now. So that's the only thing in the project settings at the moment. That will change. There'll be new things in there, but for now, that's where project settings are. The info button is just a simple about, but it's also got this useful link to the sample content, which gets updated periodically as I do releases. So useful to know where what that button's for. So then the guts of the tool itself, this tab bar here, and the contents of each tab. So we'll go over each one in turn, and again I'm going to rush through this very quickly because there's a lot to cover and I don't want to drag it on for too long. So in the screens view, screens, I'm not going to go into explaining exactly what they are, but they're fairly obvious. They're a group of instruments and an optional game window. So you can create instruments in here and move the instruments around. Instruments can be various different types. So you access those through the properties button, and you've got type integer, text or tile. All of this covered in previous videos, and you can place them and name them. So you can have multiple different instruments and set up your screens. And the screens don't have to have a game window. This one does at the moment, and if we set it to not a game screen, you'll see the game window disappears. That's so you can use screens for menus, high scores, all sorts of different things. The other thing you can do in screens is paint with tiles and brushes, much like you can in rooms. So you've got this assets section down here which doesn't have objects in. You can't place objects in screens, you can only place tiles. So if we select a tile, you can paint with tiles in your screen. Bear in mind that if your screen does have a game window, any tiles that are intersected or within the game window just won't show, because the game window will override them. So typically you'll use the tiles for drawing outside of the game window for laying out your game screen for console type effects and that sort of thing. You can do all the other tools using this. This is the tile map editing, common tile map editing toolbox, which will be used in the rooms as well. So you can do colouring in here as well, in the same way as you can in a room. So tile map editing is common across both. You can edit tiles within here, so you can create a new tile. So the tile editor, again, common to room and screen. So we can draw a new tile in here with whatever you want in it and start drawing with that tile straight away. Tile properties within the tile editor. So each tile can have a set of default properties, including default colors, excuse me, default colors and collision information. These are some of the optimization tools you have, and a unique type, which just identifies that type for logic. So logic can query the type of a tile. And multiple tiles can have the same type. So you could have a water tile and a lava tile that are both liquid, for example, or both use the liquid identifier. So that, and then your logic can behave based on whether a tile is liquid or not. Brushes. If I turn off the game window so we can see what we're doing again. Brushes allow you to create collections of tiles and then reuse them. So I can paste that brush in multiple times now, and they're very efficient. Each use of a brush will just take up a small amount of space compared to all of the tiles in it. So that's a very powerful tool for creating more complex tile maps. And again, it applies both in screen and room. Wherever you're editing a tile map, the brushes apply. We can delete those brushes as well. That's tiles and brushes. We've got some tools down here, so we can flip tiles, and you can see it changes immediately, and up and down as well. You can move the pixels of the tile around, so you've got some rudimentary tools for creating your bitmaps. So I mentioned the tile map editing toolbar here. This again is common between the screens and the room tile map editing. It allows you to select ink color with the left button and paper color with the right button. You can see them show down here in the indicator. You can choose your tile and it will show down in the indicator too. And you got a brightness, so you can have bright on or off. And these are the colors that you'll be painting with if you choose the roller. You paint with the roller and it'll paint tile attributes over those tiles. You have the trowel, which basically pastes tiles. In each case, the left button places, the right button deletes. So if you're in trowel mode and you push with the right button, it deletes the tile at that location. And if you're in roller paint mode, it'll delete the attributes at that location with the right button. Then you've got move, which allows you to move all of the tiles around. So if you've got something not quite right and you want to reposition the whole room, then you can do that, or the whole screen. This is for copy and paste, so you can select a tile region, copy it and paste it. That's pasting all of those tiles. It's not a brush, it's pasting it. But the selection mechanism is also used for creating brushes. As we saw earlier, I can create a brush from the selection and it captures everything, including the attributes. And then we've got paste brush, which allows you to select a brush and paste it into the screen. And again, right button will delete a brush. Paste it, delete it. Below that you've got a bunch of layers. Now this does change between the screen and the room tile editor, because certain features aren't relevant in the screen. So in this screen you can turn off the grid, the tiles themselves, the colors, so you can just see the tiles without the attributes, and any brushes. So if we paste a brush and turn that off, then the brushes will disappear and you're just seeing tiles. I'll cover the other layers when I come to the room in a moment. So down here you've got some indicators of where the mouse is and then different coordinate systems. The white is in pixel coordinates on the screen with 0, 0 up to the top left and the screen size down at the bottom right. The cyan in this case is the tile coordinates, so you can easily see which tile coordinate you're under 8x8 tiles. And the green, which is currently not selected, if I Yeah, it doesn't really apply in the room editor, but in the screen editor, but in the room editor, there's these are object coordinates. Okay, and then still within the screen you have logic. So this is a common logic editor that will apply wherever we're editing logic. Right click allows you to create a node. You can filter down the nodes just by starting to type, and you connect with by dragging between the ports. Drag off to disconnect. I won't go into the logic of how that works. There's another video which I'll link in the description below, which describes how the logic works. And we've got a couple of features in here, so cut, copy and paste, so you can create select multiple copy and paste if you want to reproduce whole sections. That's it for the logic. We've got variables over here. So each area where you can apply logic, which is screens, rooms, objects, global, you can create variables, call it whatever you like, and create as many as you like, and they can be accessed. For accessing the variable values, either setting or getting, you use a set variable or get variable node, and that allows you to just choose the variable, or much more conveniently, if you drag the variable in with the left button, it's a get, and it's already populated with the correct variable, and a right button, shift left button will bring in a set. That just makes it really easy to, so if you had multiple variables, you could bring in that and it automatically populates it. So just a convenience factor. So that's logic. That covers everything. I won't go into logic again. I'll just point out where the logic is available in other tabs. So move on to data. The plan is to have different data types, but at the moment all we have is text, and these are only really used in instruments. So you can have an instrument that has, go to layout, you can have an instrument that is of type text, and that allows you to choose a message from here. So if we create a message, something, and then we go to our screen, then that instrument has the that text in it, and you can define any number of messages here and delete them. That's the only place you can work with text in Kwyll at the moment, is in the data and in the screens. So data very quickly. Sprites, sprite editor, very rudimentary, very simple. You can have multiple different sprite sheets. Each sheet can have its own properties, which include the size, the width and the height in increments of 8 up to 32. So you can have up to 32 by 32 sprites, and they don't have to be equal, so it can be 16 wide by 8 high, or more likely something like 8 high by 16, 8 wide by 16 high. And you can choose whether or not to have a mask. A mask I'll show in a second. So that just basically changes that sheet. When you change the dimensions of a sheet, unfortunately you do lose everything. So let me just reload that one so I can show you a mask again. So the way the mask works, this sprite sheet, the main sprite sheet, does have a mask layer. And the way the mask works is when you're painting in ink and paper. So you paint with the left button and delete with the right button. So we can delete that and it goes to the background color, which is always black and white when you're working with sprites. And the other mode you've got is a mask. So if I delete that, I'm deleting the mask bits. And when you're painting with mask, it shows up as this checkerboard pattern. What that means is if you're using a masked sprite in the game, and you use mask mode, which I'll show you when you get into objects, the background will show wherever this checkerboard any pixels in the background will show wherever this checkerboard is visible, so it overlays rather than wiping out. And you got a couple of the same tools that we had in the tile, so you can move the sprite around, and it just scrolls over to the overruns and scrolls over to the side. And you've got flip and mirror, so you can turn the character upside down very quickly. That's basically it. You can create multiple sheets, as I say. You can add sprites and duplicate sprites, so we could duplicate this one, and we've got a copy of it to work with to change however you want it changed. Multiple sheets with multiple sizes, so this sheet has no masks, so bear in mind a mask does cost more memory, so if you don't need the mask, don't use it. And that's about it. So sprites themselves don't draw anything, you need to put them into objects, so that's where we get to the next tab. If we go to here, we've got a number of objects here, and you can see I've broken that sprite, so let me just quickly load up again, so we're working with something that's tidier. So an object can have any number of animations, sprite animations. You add different ones using the add and minus, and that's the one we select. And each animation can have a number of frames. So if we hit the player, for example, we've got 5 different animations here for each direction of movement and for idle. And each one currently has 2 frames. So this box here will show the current animation playing at the default rate, and you can add more frames to this. So if I added another frame on this one, for example, put the X in there, you'll see it toggles at that rate between them. In terms of properties, you have a name for it and the draw mode. The mask will only be available if the sprite sheet that's selected has a mask layer. Otherwise, you have 3 other modes: load, XOR, and OR, which I've also described elsewhere, so I won't go into the detail of. And you can set the default colors, which we covered earlier in this video. Objects also can have logic, and this is probably the main area that we will be placing logic. Everything that applied before still applies here, so all the tools, all the features, variables, different nodes, different triggers and flows and so on, all works within objects too. Moving on to rooms. So the concept of a room is it's not a place on the map as such, it's more like an object definition, so you can use rooms multiple times on the map if you choose to. So they're very efficient. They're basically a room definition, and then a map location is an instance of a room definition. So we have the start room here, 2 other rooms, and an interior, and each one has its tile map. The tiles, the tile editing, the assets are very similar to the screen which we covered before. I won't go into the details on that, but there is an additional tab in the assets which is objects, because you can place objects from the objects list into rooms. This is one such example. So the blue bubble has been dragged and dropped into the room, and you do that just by literally dragging it and dropping it in, and it will show up as a new object in the list. If we delete that one, so when you've got an object in the room, you can click this button to edit its particular properties. So this is properties that are unique to that instance of the object. So you're not changing the object definition over here, you're changing just this particular object. Flags, position. You can change the animation rate so that it plays faster or slower, and that's again per instance, so you can have the same object playing at different rates in a room, and you've got color overrides. If the object had logic with variables, they would show here. So if we open up the portal, for example, that has a variable in its logic, and you can set these within this object properties per instance again. I think this is all very similar. The only thing that's changed in here is you've got the addition of the collision information, which doesn't make any sense in the screens because there's no collision. So you can paint with the collision tool by setting up, down, left and right, which describes how objects can or cannot move through that tile. So if you set it to that, for example, no, a more common one would be that. A platformer would typically have the platforms configured with the top collide flag set. So then if you paint that, it just shows as the top, which means objects can move through it from below, left or right, but when it comes down, it'll stop at the top because it can't go through, because the collide flag says it prevents interpenetration. And again, much like before, paint with left, erase with right. And then you've got, so everything else there is the same as in the screen editor, and the only thing you've got down here that's different is the addition of the collision layer. So you can turn off any collision information if you want to, if it's getting in the way when you're doing other things in the room. As well as objects, you've got this feature here, markers, which you can see there's 3 placed in here. Markers are similar to objects, but they're very lightweight. They just have a position, no visual representation, no logic, no nothing. They're just literally a point in space, and you can access that point information within the logic. Makes it very useful for things like spawn points. If you wanted your spawn point to be there, you make your logic move an object when it's spawned to that position, and then if you decide later, actually I want the spawn point to be up here, you just move the marker and everything continues to work. So a very useful tool. Brushes exactly the same as in the screen editor. Here you can see the difference in these three coordinate indicators. You've got the pixel coordinates, which are pixels within the room. You've got the tile coordinates, much like the screen editor, and then you've got objects. So if you select an object, it will show you the currently selected object position, and it will retain that position in pixel coordinates until you select another. That's very useful for identifying where things are. The last piece in the room editor is the timeline animation, which I can best demonstrate by loading a different test file. So in here we have an object bubble, and you can this only works in the room editor, but you can apply keyframed animations effectively to the position of objects in a room. So you can see here in this timeline here, we've got a number of keyframes put in. Right, if I go to the edit mode, right click, you can see it has a position and an optional T value, which I'll explain in a moment. And if you go to play and drag the timeline pointer, you can see we've got the keyframe there, and a keyframe there where it's at a different position, and then a keyframe there, and you can play these animations. And you can have multiple animations on an object. So this bubble has 2 animations. That one that does an upside down V, and then there's a simpler one with just 2 keyframes, which just moves between those 2 keyframes. You can have as many keyframes as you like, and it can go on quite some time. So you can create complex animation sequences and sets of them in the animation editor. Moving them is as simple as going into record mode, move the object, and insert a new keyframe with the key button. The map is where you bring all your rooms together. So into a map, you don't have to have them adjacent or connected in this way, but it's convenient to do so, and you can drag as many different instances of a room. So I can drag another version of that room in here. I can drag the start room back in if I wanted, in there, and each one of these is fairly lightweight on the map, which allows you to create a complex map with a few number of rooms if you're careful about how you reuse them. And if you watch the tutorial I go into a lot of detail about a technique to make that even more powerful. And again, you can drag in objects, so you've got objects down here in the assets list, the same objects from the same objects definitions tab, but when you drag an object into here, you're dragging it into the map, not into a particular room, so it can exist anywhere on the map. Usually reserved for the player. The player is, in most scenarios, the only thing that needs to be able to move from location to location, and therefore exists in the map rather than in a room. But you can use it, you can use that facility for anything you like, and you can just drag multiple objects onto the map. So moving on to the sound, we've got ultimately there'll be different approaches to making sound depending on the platform you're running on, but for now it's just simple 4K Spectrum beeper effects. So this is using the beep effects library from Z88DK. So you create a sound. Each sound consists of a number of blocks. A block can be of any type of tone, noise, or a pause, and you combine them to create more complex effects. So if I load the beep effects example, we've got a bunch of different sounds in here. So if I pick a more complex one, if I can find one, there you go. So the boom, if I play it, see, you can hear that. Has 3 blocks: a noise, followed by a tone, followed by a noise, and then these parameters just control the nature of that particular block. I won't go into the details of how it works, but that's how you define sounds. Each sound has a number, and there's a logic node to play a given sound number. That's simple. Another logic tab. This is for global logic. So this works in exactly the same way. It has no object associated with it. It does have variables, but it's just for logic that applies across the entire game. And then finally we've got the preview, which is a simulator. And if we play, then you see it plays all of the features that Kwyll offers. So if I load a game, it plays, all the logic gets executed at runtime in the graphs. So there's no export, it's just running the logic from the graphs. And it allows you, it doesn't pretend to be an emulator of the Spectrum, it's just a simulator of the Kwyll system. So it does all the logic. It's mainly for testing that your logic is doing what you expect it to do. All of the features work, so you can move between rooms and so on. And over here you've got a running information tab that just gives you useful information, so you can see the position of objects change as you move around. Any variables that are on an object you can show. So if your game isn't behaving as it should be, this is your first port of call to see whether the logic is doing what you expect it to do in terms of setting variables and so on. And then down here we've got an information panel. Any errors that occur during simulation will show up in red in there, and some information and warnings. So as you're developing your game, if you see any errors in here, take note of them, go and see what's causing them, because chances are if they're causing error messages in the simulator, they will cause crashes on the Spectrum. And then the final part, down here we've got a memory indicator. This updates when you do an export or when you run the code window, which creates the exported data block. At the moment it just shows you how many bytes you're using. Before release I will have finalized the engine and work out how much available space you have, and it will show you of how much available space you've got down here as well, so you can see when you're getting close to your limit and when you need to start optimizing your game. So that's a quick whistle-stop tour of all the features, I hope. I think I've covered most of it. If I've missed anything or you feel anything wasn't covered with enough detail, drop a comment below and I'll try and get back to you, or pop over to the Discord and we can have a chat, and I'll explain any details for things that you think weren't adequately covered. So before I leave, the other thing I wanted to cover very quickly was the release plan. I do plan to release a beta, public beta, in the next month, 2 at the most. Once I've done some optimization work, I need to spend a bit of time on the Spectrum side of the code to free up as much memory as possible and make it as performant as possible. Once that's done, I'm ready to go to beta. The features that you saw today are pretty much what's going to be in there, I imagine. I've got a couple of other ideas that I might consider adding, but they're small and relatively straightforward. Pricing, undecided for sure, but it'll be somewhere between £9.99 and £19.99, equivalent in other currencies. Probably distributed through itch.io. I'll do another short video at the time I'm ready to go to public beta, so I can send the link and the pricing details as and when. The beta will be a public beta, so it'll be basically you're buying the game creation tool as on the understanding that there are some things that may need to be cleaned up, and I'll be releasing updates fairly regularly during that beta period to solve issues that get raised, until things settle down and it becomes more stable, and then it'll be released as a 1.0 final release for those who are less willing to play with things that might break. So that's the release plan in a nutshell. I'll give you more details as I've got it. So just to finish up, as always, if you like what you see, leave a like, subscribe for more updates, especially the public beta release update. Join the Patreon if you want early access before the release, and to support the project in general. Pop over to the Discord and have a chat and tell me what you think, what you like and what you don't like, what you'd like to see changed. And I'll leave you now with a list of the nodes, so you can see it'll be I'll leave it to scroll in the background with some music, and you can see just how comprehensive, even at this first release, the amount of capabilities in the logic, and hopefully you can get an idea of the sort of games that you'll be able to create with Kwyll.